After 50, our next question is 21st question. 21st question is Norton's theorem. So already we discussed Thevenin's theorem. So that Thevenin's theorem is completely opposite of this Norton's theorem. Okay. So in Thevenin's theorem we are taking a voltage source. Here we are taking current source. In Thevenin's theorem we are calculating VThevenin, the RThevenin and IN. Here we are going to calculate IN, I mean Norton's current and Norton's resistance, and same like Thevenin's theorem also, here we are calculating load current. That's it. But you remember what are the major difference between a Norton's theorem and a Thevenin's theorem. The first one is, in that particular Thevenin's theorem we are taking Thevenin resistance, and here we are taking Norton resistance, and in Thevenin's theorem we are taking voltage source, here we are taking current source. And the major important difference is, in Thevenin's theorem we are taking Thevenin's resistance in series with the voltage, but here we are taking that Norton's resistance in parallel with the current source. So voltage source in series with the Thevenin resistance and load resistance in Thevenin's theorem. Here we are going to take current source in parallel with the Norton resistance and as well as load resistance. That one only our statement, you remember. Same here also in Norton's theorem also I have simplified statement. Current source in parallel with Norton's and load resistance. So related to this statement I have drawn here circuit diagram. Okay, so Norton's currents in parallel with Norton resistance and as well as load resistance. That one only the statement. According to that statement I have drawn the diagram. Okay, here IN is a Norton's current and RN is a Norton resistance and RL is a load resistance. Okay, so our first calculation is theoretical calculation is Norton's current. Previous Thevenin's theorem we are calculating, first one is VThevenin. That VThevenin place we can replace IN, Norton's current. The conditions is load resistance will be a short circuited and calculate total equivalent resistance by using circuit reduction technique. This condition is same in that Thevenin theorem and here also. But in previous case, in Thevenin's theorem, load resistance we have done open circuited. So that is the one more major important difference between Thevenin's theorem and Norton's theorem. But here load resistance will be short circuited. Okay, so that is the major difference between Norton's theorem and Thevenin's theorem. So according to these two conditions I have redrawn the circuit diagram. So source voltage and remaining resistances are same, and there is no any change in internal resistances, and load resistance only I have done short circuited. Okay, you remember this important difference between Thevenin's theorem and Norton's theorem. Then we will go for formula. And formulas for Norton's theorem. So you remember we are calculating IN current. So for IN current, applying a current division rule. What is that current division rule? IN equal to total current IT and into opposite resistance by total resistance. Okay. So how we are taking this opposite resistance and total resistance in a sense? You remember here where we done a short circuit, from that place only we are taking opposite resistance. So for this short circuit, opposite resistance is R2 resistance. Okay, so R2 by total resistance in the sense these two resistances, R2 plus R3. That one only I have written here. Opposite resistance is R2 and total resistance R2 plus R3, and I total current this one. Okay, and from this we are calculating a total resistance from the above circuit. The same thing is applicable here also. where we done a short circuit. From that place only we are going to do a circuit reduction technique. So that's why these two are parallel resistances. That's why R2 into R3 by R3 plus R2, and for these two parallel resistances, this R1 is a series resistance. That's why I have written here R1 resistance. Okay, and totally IN equal to V by RT. So this is a RT, total resistance, equivalent resistance in the circuit, and V is a whatever it may be the voltage in the entire circuit. Source voltage we are giving now. So in this particular circuit, that source voltage we are taking here. Then we can calculate the Norton's current. Okay, then we will go for calculation of Norton resistance. So calculation of Norton resistance is same as a Thevenin's resistance calculation, but you have to replace Thevenin's resistance plus Norton resistance. That's it. Remaining all are same. Conditions, three conditions also same. Okay, and you have to redraw the circuit diagram also same. Thevenin. So it's mean always you remember and you practice that Thevenin's theorem resistance calculation. The same conditions, same diagram, same formulas you have to write it here. That's it. There is no any change between Thevenin's theorem resistance calculation and Norton's theorem resistance calculation. But you have to replace R Thevenin plus Rn, Norton resistance. That's it. And formula also same, R1 into R2 by R1 plus R2. It's mean these two resistances are, so already I said always one condition where we done a short circuit, from that place only we are start to do a circuit reduction technique. So from this point of view you have to do a R1 and R2, these two are parallel. These two resistances are in series with this R3 resistance. Okay, that's it. Then we will go for load current. So already I said the difference between Thevenin's theorem and Norton's theorem. So here previous case Thevenin's theorem voltage source, but voltage source place replaced Norton's current, and Thevenin's resistance place we have replaced Norton resistance. That Norton resistance also in parallel with this current source, and load resistance also we are taking in parallel with these two values. So formula is according to applying a current division rule. So IL is equal to Norton's current into Rn by Rn plus RL. Okay, so this is our formula. So this is also we can remember according to Ohm's law. So I is equal to V by R. Okay, so V in the sense again we can take it IR according to Ohm's law. That IR we are taking upside current division rule. Okay, I into Rn by Rn plus RL simply.